In today's video, I'm going to teach you how to differentiate from first principles. So whenever you're differentiating from first principles, you have to use this equation that says that the derivative is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. You just need to remember this formula and just memorize it from heart, off by heart. So let's say, for example, f of x is equal to x squared. For example, I'm going to teach you how to differentiate from first principles of x squared. So basically, you have to say f dash of x is equal to the limit as h approaches 0. Now, this is the tricky part here. So the x plus h replaces the x. So you just say x plus h squared. So the x plus h just replaces the x squared. And then the f of x obviously stays the same. It's just going to be x squared all divided by h. So now, always put the limit as h approaches 0, by the way. You always have to put limit as h approaches 0 every single time. Always put limit as h approaches 0. We can expand the x plus h squared to get x squared plus 2hx plus h squared minus x squared over h. This equals the limit as h approaches 0. See these x squareds? They cancel. That's how you can tell if you've done it right. If these cancel, then you've done it right. Now we can just write 2hx plus h squared over h. Now, we've got a h on the bottom, both got h's here, so we can factorize the h out like this. That's also something you have to learn. When you've done the cancelling, you can factorize out the h, and then these obviously cancel. So we just get the limit as h approaches 0 of 2x plus h. And now we can say, as h tends to 0, f dash of x becomes 2x. So basically what we're saying is h becomes infinitesimally small. We can just treat it as 0. So say that it's just 2x plus 0, so 2x. So there we go. We have just differentiated x squared, differentiating from first principles.